Welcome to this course OC MBA 112 Business Data Analysis for Management Science. Week 8, Lecture 5. Replacement Problem. Sum number 1 by Dr. K. Sankar Singh.
In the previous session, we discussed what are the situation we need to replace the machines, why we need to replace the machine, and what are the advantages of replacement. In this session, we are going to discuss the replacement problem related numerical sum. The given problem statement is the cost of a machine is rupees 6100 and its scrap value is rupees 100 only. The maintenance cost are found from past experience to be here year from 1 to 8 given. For each year maintenance cost here given. So maintenance cost, that is for the first year 100, second year 250, for the successive year 400, 600, 900, 1250, 1600 and 2000. Suggest the optimal replacement period. At what age we can replace the machine. So this is the given problem statement. So here maintenance cost. The maintenance cost is included the operating cost and the maintenance cost. Here in this replacement problem, there are lot of costs are involved like maintenance cost, replacement cost, running cost, operating cost and purchase cost. Here maintenance cost is given. Cost of the machine is 6100. The scrap value is 100 is constant. Here how can we calculate the depreciation? Generally we can calculate the depreciation using the value cost price minus scrap value. Here cost price is 6100 and the scrap value is rupees 100 for all the years. So in this problem constantly depreciation will come. Depreciation 6100 minus 100, that is equal to 6000 is depreciation for all the 8 years. Here in this replacement problem, we should find the average cost for every end of the year. So that's why we draw the columns. The first column titled with the replacement at the end of the year. Second column maintenance cost or running cost. Third column cumulative maintenance cost. Fourth column C minus S, that is depreciation, and the fourth column is total cost. How to calculate the total cost? Cumulative running cost plus depreciation, then average cost. For each total cost we can divide it by its respective end of the year. So finally we will get the average cost for every end of the year. For example, replacement at end of the year. So we can assign the year number of years from 1 to 8. Running cost, here maintenance cost will be considered as running cost here. So what are the running cost here given? For the first year 100, second year 250, 400, 600, 900, 1250, 1600 and 2000. Here we can write as per the problem statement. And the third column total running cost or cumulative running cost. So for the first year 100, for the second year means first year 100 plus second year 250 up to second year first two values total 350 up to 3 year first three values total 750 up to 4 year total 1350 up to 5 year total running cost 2250 up to 6th year total 3500 up to 7th year running cost total running cost or cumulative running cost 5100 and up to 8th year 7100. So these are the cumulative running cost or total running cost. Then depreciation. How to calculate the depreciation? Using the relationship cost price of the machine minus scrap value. Here cost price is 6100 and the scrap value is only 100. It is constant for all the 8 years. So we can easily calculate 6100 minus 100, that is equal to 6000 is a depreciation for all the end of year. Then fifth column, total cost. How can we calculate the total cost? Total running cost plus total depreciation. So we can summing total running cost 100, depreciation 6000. So 6000 plus 100, 6100. For the second year, total running cost 350 and depreciation 6000. So 6350. Similarly, we can calculate till the end of 8th year. After that, average cost. How to calculate the average cost? Using that, we can divide the respective end of the year. Total cost divided by respective end of the year. For example, first year 6100 divided by the respective end of year 1. 6100 divided by 1, 6100. Then 6350 divided by respective end of the year 2. So 6350 divided by 2, 3175. So similarly, we can calculate average cost for every end of the year. After that, how can we conclude this problem? How can we find till which year we can use this machine? When we can, after which end of the period we can replace this machine? So we can consider the average cost for every end of the year. From first year onwards, 6100, 3175, 2250, 1837, 1650, 1583, then 1585. So in here, in the last column, average cost from the first end of the year to 6th end of the year, the average cost will be decreased. After end of 6th year, 7th year onwards, the average cost will be increased. So we can replace the machine after end of the 6th year. The machine has to be replaced at the end of the 6th year or at the beginning of the 7th year, as the maintenance cost of 7th year become higher than the average cost of maintaining the machine at the end of 6th year. So we can replace the machine optimally at the end of 6th year. This is the suggestion for the given problem statement from replacement problem. Thank you.